Now you're going to accompany us with the camera. All right. Okay, we have let's just step over this way. We're going to talk through all the different steps here, and then we'll demonstrate taking the core, and then we'll collect more cores amongst all of us to have a few cores that we can use later on to mount and to sand, so that you go through all the steps of the process. Sorry, this makes it more challenging for you. It's pretty wet. It is. I'm going to set this on the bench. Okay. How many people have used increment boards? 3? No one else. Okay.
Yeah, I did once.
Ah, okay.
Yeah.
Okay. So a little bit. So this is the basic tool of dendrochronology, is the increment board. This removes a small sample from inside of a tree. We can also, of course, as we talked about yesterday, use complete sections. So we can use a saw to take a complete circle of a tree trunk. But in the case of trees that are standing, living trees, and even those that are standing and dead, that means that we would have to cut the tree down. So it's very helpful to have this small tool that you can use to collect a sample from inside of the tree. So the increment borer consists of 3 parts. This unscrews, and we have these 2 pieces inside. So this that has the threads on it is actually the drill. This is the borer that goes inside of the tree. It clips into this handle like this, and that makes a drill. It drills into the tree. The inside of the borer is hollow. So as it drills into the tree, a tube of wood is gradually building up inside here as you drill and drill and drill and drill until you have reached the center of the tree, or a little bit past the center, then you stop. And this third piece is called an extractor, or sometimes it's called a spoon, like a spoon that you would eat with. A little bit because of the shape, because it's cupped like this. And the spoon slides in next to the core. Then you go back. When the spoon goes in, it pushes the core at the very end. When you back up, it breaks the core away from the rest of the tree. And then you can pull this piece out, and the core sample comes out on top of the spoon. Okay, I'll pass it around and take a look. So I'm going to pass this around too. Something to, morning. So in order to be careful with these increment borers are small, like you see, and they don't seem very complicated, but they're very expensive because they have a very fine point here, very sharp threads, and because the steel is extremely strong. The steel is so strong because you're putting a huge amount of torque on the metal as you twist it in the tree. As you will see today, because the trees here are very hard. We are not in the position of having a lot of soft wood around the campus here. These are mostly hardwood trees that have quite hard wood. So our goal for today is to try to get some cores out without doing any damage to the increment borers. But anyway, all that means is that these are sort of expensive. How much do you think this might cost? 40,000. So that would be like $500.
Yeah.
Not that much. One of this size costs about $200. But because that's still a lot of money, we want to be careful with it. So the most important part is the tip. If I drop it, nothing happens. But if I drop it and the tip hits even the soil or especially a rock, then it would be, it gets nicked. It's very fine, very sharp edge. So when you hold it, you don't want to hold it like this, because this thing is pretty loose and this can fall out. So you always want to try to make sure that that's clicked in, but then you want to hold it maybe like this, but not like that. Okay? Thank you. Here, we can pass this around too. So take a look at it. Let's open up another one. This is the longest one that we have with us. Pass that around as well. And then we have a third one. So we have these several different sizes. They're all very similar except for the size. But the costs are exponentially higher. So if you add 10 centimeters, you double the cost. They get much more expensive because the steel has to be very, very good to resist that pressure of the reflexive.
Does it come with different dia as well?
Diameter?
Yeah.
So there are two main diameter sizes that are available. And these are the slightly larger. Okay, there's more than two. There's two that are commonly used. This is the slightly larger size. There's one that's a little bit smaller. Both of those are commonly used for dendrochronology. There's also a much larger increment borer that is approximately a centimeter in diameter. And that one can be used for certain trees where the rings are very hard to distinguish, and so you want to have a bigger sample. And often archaeologists also use those large diameter borers. So if they go into an old building and the goal of the study is to try to determine when the building was built, then they may use these larger borers. The large ones, the big diameter ones, are always quite short. They're like this length. They can't make a big diameter one that's very long.
So the diameter is standardized or just like that, something to be pulled out?
There are two standard sizes. Yeah, I don't remember what they are in millimeters right now.
Yeah.
But
4.3 millimeter. 4.3 mm.
okay.
Why 4.3? That is the question. Whether it is standardized or yeah.
Just because
Just
the
because.
manufacturers
Yeah,
agreed on it.
yeah.
Right there, at one time there were several manufacturers of increment borers. Currently, there are only two companies, both in Scandinavia, that make increment borers. It's a very specialized field because the only people who use this tool are foresters who are trying to measure the age of trees in the forest, and dendrochronologists, and there's not so many of us.
Yeah.
So we don't make a big market.
On demand.
Yeah. Okay. So while we have the borers out, I wanted to show you what's happening inside. So this image, you see the cutting head of the increment borer going inside the wood. And the things that are happening is that the metal of the borer is pushing, it's cutting through the wood, and it's also pushing the wood away. So the core that's in the center is free floating. It's loose in the center of the increment borer. The extractor in next to it. When the extractor's all the way in, it locks against the wood, and then when we turn it back, it breaks the connection inside of the wood. Hello? No worries. Yeah, let me see if he mentions the standard sizes here. I don't see that. Later on we'll show the process of mounting the core as well, and you'll see that you want to have, you will make mounts. Well, one makes mounts for the cores, and then you want the size of the mount to match the size of the core as well.
What if CVH is so high, like so big, the tree is so big, so we won't be able to reach up to the middle?
That's why this is kind of long and short.
What if bigger than this?
There are bigger increment bores size. It costs it's quite expensive. And in the case of some of the trees here with very hard wood, I don't think it would be possible. But in the case of, the conifers, with large conifers, you can reach quite a long ways. But there are species of trees that are too big to be able to use an increment board in order to get all the way to the center.
Generally, when we go to uphills, then we find much bigger trees. You have to use bigger ones.
Yeah, but this one, so if this was all the way in the tree can reach this size approximately, and so that's not too bad. All right, let's close these up. So to close them, you unclip them, you slide them back gently into their slot, and then you put the spoon or the extractor back in. So here's the other. And now that slides all the way in, and then it screws shut. No, it goes inside. Yeah, it slides right inside. All right. Did you guys get it closed up? Okay. All right. Good job. So let's talk about some of the considerations that go into sampling a tree, and we can discuss with the trees in the garden here, for instance. So let's. Boy, that rain was nice. Things were dry and dusty. Now they're clean. Okay, so where should we sample this tree?
1.3.
So we got some breast height advocates. Anybody else? Why would breast height be a good place to sample a tree? Standardized. Is everyone familiar with that term, breast height, or that specific height? Okay. So it's a standard height in measurements of trees. Standard in every country except in the United States, where it's 1.37 instead of 1.3. But everywhere else in the world, it's 1.3 meters. And to reach around and take the measure the diameter of a tree. So for certain kinds of measurements, it would make sense to sample at breast height. For example, if we are interested in the growth of the trees in the forest, for example, for management plans of a forest or for management of a plantation of trees where our main concern is the growth of the stem, the standard place for measuring the stem is at breast height. That's where we measure the so-called diameter at breast height. In India, though, the measurement is often called the girth, right? Yes. And the girth is the circumference, right?
CBH.
Okay. So diameter is the cross-sectional distance, and then girth or circumference is the distance around. And one can be converted into the other mathematically. So that's the standard place to measure. Thus, if I extract rings at this height, and I measure how much the tree has grown in those rings in the last 5 years, then if I subtract that wood growth, I would have the diameter of this tree 5 years ago. Or I could calculate 10 years ago, 20 years ago. In other words, I can calculate the growth rate, the diameter at breast height growth rate of my trees. So in that case, I would probably want to measure at breast height. Another reason for measuring at breast height is that there are many equations that are used to express other important aspects of the tree, such as its biomass. And these equations are called allometric equations, where typically the independent variable is the diameter, and then we can estimate, often quite accurately, the biomass or the mass of bark or wood or branches or leaves, etc. So that's very useful not only for forest management, but then for other kinds of applications like measuring how much carbon there is in the forest, for instance. So we can calculate biomass and convert it to carbon. So those are all good reasons for measuring at breast height. However, sometimes we want to measure at places other than breast height. Why might we want to measure somewhere else?
Maybe there is some fire,
Like
branches catches fire from below the
Yeah, surface fire.
The
Yeah.
surface, if we want to add the
Fire scar.
germination date when it has started to grow, so we will take on the at the ground level.
Okay, so we'll come back to the fire scars, but this point is one of the most important reasons for trying to measure close to the ground, the total age of the trees. And so, of course, trees grow outward, but before they can grow outward, they must grow upward, right? So trees that start out as seedlings or sprouts, if they are sprouting back from a below ground root, from a rhizome, they take time in growing upwards. Sometimes it's a quite short amount of time, so there are some species, particularly in wet tropical environments, that might reach breast height in perhaps 2 years. On the other hand, there are some other species, particularly those that are very tolerant of shade, or late successional species in a forest, that may take decades to get from a low height like this to a height of 1.3 meters. So in those cases, we would be missing the total age, underestimating it by quite a bit. So for the purpose of age, it's often desirable to try to core very close to the ground. It is difficult to core at the ground surface. You've seen that the increment bore has a double handle. The handle has to be able to rotate. Some of the ways that people have developed to try to deal with that situation are to core at about 10 centimeters or so at an angle, so that the increment bore is angled in towards the center of the tree. That's imperfect, because later on you'll see that as we mount the wood samples in order to prepare them to look at under the microscope, it's very important that we're looking in cross-section at the wood. So if the wood is at an angle, we're not looking in cross-section because all the cells are actually tilted. However, in some cases you can still see it well enough to try to get to the center date. Another thing that people do sometimes is core straight at a particular height, like 20 centimeters or 30 centimeters, and then either in their study say this is the age at 30 centimeters as opposed to the age at the ground height. Or they may also do another part of the study where they sacrifice some seedlings that are small trees, cut them down at ground level, and measure how many years on average it takes for them to grow to 30 centimeters. So that's a type of adjustment that one can do. Okay?
Otherwise, we can remove this from soil from the here and put the here, then rotate the handle.
Well, you possibly could.
Yeah.
I mean, the tree has roots going out in every direction, so you may not even have to, cut through the roots to dig out enough of a trench. However, in natural situations, trees are often on slopes. And so some people trying to get total age go to the downhill side of the tree, where the soil tips away from the tree trunk, and then they try to go in at that, from that point. So that's similar to what you were saying. Okay. In terms of sampling for certain other kinds of features, in the case of fire-scarred trees or trees that have a scar. We'll see some scars when we walk around this morning that are not, well, they're probably not caused by fire, but scars can be caused by many things, and scars can be dated. If a tree only has one single scar, then it is possible to try to use the increment borer at the height where that scar is, penetrate the healing surface, and then go into the scarred area and extract the sample that potentially will allow you to date when that scar happened. So that's a possibility also. One other situation that happens a lot in forestry is on this tree right behind us here. How many trees do I have here? Two. If I count them as stems at breast height, I have 2 separate stems. How many living organisms do I have here? 1, really, right? And this tree really has 1 age to it. It doesn't have 2 separate ages. It's just a forked tree. So in the case of a lot of forestry applications, there are often rules that guide this situation. So the rule might be treat it as 2 trees, or the rule might be drop down below the fork and take a single diameter. It depends what the inventory rules are. From an ecological point of view, typically this is the kind of case where we would probably want to think of it more as 1 tree rather than 2 trees. From the forestry case, if these were big trees that had value in the logs, then we might prefer to think of it as 2 trees.
So when we add the CBH or DBH of this, if we consider it as a 1 tree, will we add that growth years of this branch as well as this branch?
It will have an similar growth.
It would depend on how you're trying to treat the tree. So in some forestry applications, you might take 2 different diameters, and you might actually take 2 different cores if you were going to treat it as 2 trees. But for a lot of ecological studies, it might make more sense to think of it as 1 tree and take a core down here. And then people can also take a lower diameter. So another height of diameter collection, well, there's 2 actually. One is called diameter at stump height, which is about a 30 centimeter diameter. The stump, of course, is what's left behind when you cut the tree down. We're not cutting the tree down, but at that height, approximately, one could take a diameter. And then yet another diameter is called the diameter at root collar, which is at the ground surface or the place where the roots are joining the main stem of the tree. If you can see the roots, in this case we can't. So those are other options that people could use. So the point of this discussion, when it comes to collecting a core from a tree, is I'd like to have you guys be clear that number 1, there's not one single way to do it. It depends on what kinds of questions you're trying to answer with this data set. Point number 2 is that the 2 most common places are either at breast height, 1.3 meters, or quite close to the ground with the goal of trying to estimate the total age of the tree. Those are the 2 most common sorts of places. There's one other research example.
Just a minute.
Sure.
If we take core from this one and treat it as an individual, and this is another individual, they will give the same age or differently.
They should.
They should.
Because they are,
Yeah. But it depends on girth or something else also.
The only way that since this tree is forked,
Yeah.
so it divided and grew in 2 separate stems, and they should be the same age.
Yeah.
The only way it could be of a different age is if it was a branch rather than a fork.
Right.
even if forking is
Yeah.
at different
Yeah.
heights,
Yeah.
so that will be different ages.
Different ages or
Should be different ages.
should be different ages or the same, all the same.
I'm sorry, I'm not following the question very
For
well.
example, we take core from this branch,
Yeah.
and then take from this branch.
Yeah.
They look alike, similar in girth, more or less. But whether girth is taken into account while taking the core, or it is independent to girth.
So,
Means how they should give the same age, identical. If we take core from this
I think
one,
they should give the same age.
yeah.
yes.
But if the girth is different,
But the girth
and
could
it
be
is
different.
forcated from, say for example, at CBH, and the girth is different of the individuals, and it is not 1/3 of the, means more than 1/3 of the main bore, and we take core from both the branches, then it should give identical age or a different age because of the girth.
If it's a situation of a fork
Yeah.
or a bifurcation, then as far as I can see, it should be the same age. If something happened to
Independent of girth.
independent of girth,
Okay.
let's say that something happened to this branch. The tree forked, it started to grow, and then the wind broke many of the leaves on this tree, this side, but it doesn't die.
Yeah.
Then it could grow and be smaller
Yeah.
than its companion,
Yeah.
but it's still the same age.
Same age.
So it would have more narrow tree rings.
Okay. Okay.
If we see the example behind, again we are getting a fork.
Ideally, they should.
Yeah,
Ideally,
that is what we are
ideally
asking,
it should.
because
Yeah.
this one is thinner and the left one is thicker.
Yeah.
So theoretically, the
Yeah.
thicker one will
Yeah,
have more rings,
Only theoretically. Yeah.
much older
Yeah.
than the thinner one.
I don't know. The only way to find out,
Yeah.
well,
Yeah.
the thing is, this is the species that you thought would form rings, right?
Yeah. Yeah.
Which species?
This one.
What is the name of it?
Will it not be prudent to take the sample here? The date from when it has started walking.
No,
Yeah, that is fine. That is fine. That is fine.
But we are
We are only arguing the
each
limitations.
are of different girth size.
Age of the tree will be same here.
Perfect, perfect. But you are saying that is the age of the tree.
No. Age of the tree will be marked from here,
Perfect.
and the date from when the forking start.
No, you can get this thing from.
Yeah, but yeah.
No. See, our question is, are we showing same age or different age?
Yeah. That is the question. Yeah.
Suppose if we come to know the age from when the forking start,
Okay.
and we know the age of this.
Okay.
So ideally it should be of the same age because the date from when the forking start is the same,
Yeah.
Yeah.
and we know the age here.
Yeah.
We know the age here. So if this is thinner and this is thicker, this is thicker one, or this is a thinner one. From if this we know the age of thinner one, so we can calculate this minus mathematics.
No. That is not the question.
The size and the age are not always.
Got it. You are calculating age here. You are calculating individual ages.
मतलब पहले बार दोनों साथ
And then you are doing arithmetic addition. Interesting.
The size and the age are not always related.
No, वो तो नहीं है. वो तो
Okay, so-
species to species भी vary करेगा.
But again, just a related one. Now, if I have a plantation, age-old plantation, and I am calculating the age, and because that plantation has been done in different intervals of a half a century kind of thing, so my age will be related with the girth.
So their trees get bigger as they get older, right?
Yeah.
So in general, a bigger tree should be older than a smaller tree.
As a rule, yeah.
But
Yeah.
there are many exceptions. So the competition surrounding the tree, the damages that have occurred to a tree, its ability to be in good soil, have good resources, etc., all vary. In a plantation, theoretically, the soil is the same, the surface is similar, everything is very similar, and the only thing that would differ is the spacing of the trees. And thus, in a plantation, we actually strive to grow trees that are of the same size. So trees of the same size should be approximately the same age, but even so, for certain individuals, they could have some differences. Is that
So
get
there,
the question?
so it means there is always an empirical relationship between age and girth.
empirical in the sense that one can determine the age if the tree is forming rings and if you can date them, and one can of course measure the girth.
And
But there is not a uniform relationship. For many species, in fact, there is in the case of many species, there's very little relationship. Once the trees become mature, when it's very small, you know, then there's a closer relationship to age. But once a tree has reached 20, 30 centimeters in some species, that same tree may be 50 years old or 250 years old. And so the difference becomes very indistinct.
Yeah. Ultimately, it's experience that counts. How you interpret your data there. Yeah.
So sometimes what happens, two trees come out from the soil. Like we place one seedling, but like somehow two different branches come out from the soil, like at the very base.
Yeah,
how
like
do we
this
take-
from the base.
No, no, like
Yeah, yeah,
very
Yeah.
Like that.
Huh. So then
Even
how will
much
we
below.
take the I mean
Even much below, just
like
touching the ground
from
or beneath the
soil.
ground.
So how do we take the tree there?
So typically, foresters and ecologists make some sort of a rule. And thus they say that if the forking is perhaps below stump height, below 30 centimeters, then it will count as two trees, two separate individuals. So we would measure them each separately. Okay? Well, I wanted to mention one other type of coring at a different height. For research purposes, sometimes people climb the tree and take cores up in the canopy. And this is to look at the distribution across the whole tree of growth. We're going to talk tomorrow about tree growth, but one of the interesting features of tree growth every year when the growing season begins is that the tree has priorities. It has to allocate its resources. First of all, what would be first? What's the first priority?
Yeah. Flowering, reproduction.
Flowering. What else?
Leaves.
Leaves.
Yeah.
Yeah. And one more. Well, that's going to be part of the flowering, but that's a little bit later on in the season.
Yeah. Branching.
So the tree has to be able to reproduce. So it has to have those organs. It has to have leaves so it can photosynthesize. Especially if it's a deciduous tree, it has no other option.
Yeah.
And then roots, fine roots in particular. The fine roots have a very high turnover. Fine roots are a place where plants have to invest a lot of resources in order to stay alive and grow every year. So the wood cells are actually a very low priority for the tree. The tree will be able to survive, particularly those trees, which is most trees, that have a sapwood that consists of many years of rings. Yesterday we talked about sapwood and heartwood. The sapwood is the xylem that is actively transporting water. And so if the tree can still transport water, then the wood is a low priority. And thus all these other things have to happen first, and then as more energy becomes available from photosynthesis over the course of the growing season, the tree can get around to growing wood. When it does so, it actually begins from the top downward. So the wood cells are forming in the canopy before they are forming down here close to the ground. So the place where we measure the wood growth is actually one of the latest places in the tree to begin growing in a given season. So sometimes for the purpose of understanding these processes, researchers will climb the tree and take cores from various heights, which is quite difficult to do. All right, so what I'd like to do is go out towards the road and core a tree out there with us all together. Part of the reason that I would like to do that is that these trees in the garden here are ornamental trees. And so this brings us to an important question that dendrochronologists need to think about and read about, which is the question, does taking increment cores damage the trees? What do you think?
Damage this much as we cut down the tree.
Okay.
You can consider it as.
So a little bit of damage is what you all are saying. And of course the core is very small. It's like a pencil coming out from the wood of the tree. So compared to cutting it down, it's nothing at all. Structurally for the tree, unless it happens to be an extremely small little sapling type of tree. But if the tree is 10 or more centimeters in diameter, then structurally that is not much wood to lose. It's not going to break the tree or anything like that. But what other kinds of damages could happen to a tree from extracting an increment core? What do you think?
Insect attack.
Insect attack, okay, and fungal infection, yes. So we have both insects and fungi that could make use of this hole in the tree as an entry court, as a way to get into the tree. So later on, I'm going to send you a couple of papers. I didn't want to send them last night because I wanted you to focus on that Dendroecology in the tropics, which I would like to ask you to read for tomorrow so that we can have a bit of a discussion in class. But I'm going to send you some papers that are references for you to use if you begin a study with dendrochronology. And one of the papers is by the famous Henry Gracino Meyer, who we've mentioned several times, and it's about the use of the increment borer. And in that paper, he talks about how to use it well, how to take care of it, etc. And he also talks about damages caused by increment borers. And then the other paper is a much more recent one that includes a number of specific cases where people have encountered some problems. The main kinds of problems have to do with infection and basically with fungal infections. So while insects might seem to be a logical potential thing that could happen, people have not really observed that there is much of a problem with insects. But in some cases there have been observed to be problems with fungi. Yeah.
So in a practice, do you think putting some gel or dressing the tree might help, or people do that?
So the people have tried that, and they have tried several different things. They've tried putting something that's like a gelatinous or soft or waxy material in the hole, and in other cases people have tried to put like a wooden plug of some sort back into the hole. And it's believed that these do not help in any way, because the fungus had the opportunity to come in at the time of extraction of the core. But these things, this material that people stick in the hole, may also bring something with it. And it seems, in the cases where it's been looked at, this is discussed in those papers I'll send you, that if anything, it ends up rotting out around the little thing that you stuck in there, rather than if you had left it alone, it would probably be all right.
So this could be a potential research area.
It could be, for sure. Yeah. Yeah. This could also be a potential topic for somebody if you're interested in any of the things that we talk about, like today and tomorrow, that sounds of interest to you. This could be your topic for your project and presentation at the end of the course.
So
Okay, so go ahead.
does trees have capacity to get back after the...
Yeah, so let's talk about that for a second. So, on the one hand, we just brought up that taking a pencil of wood from a tree could potentially be bad for it. On the other hand, if you think about what happens to trees every day in real life, there are squirrels and monkeys and lightning and windstorms and all kinds of things happen to trees. Branches break, bark is scraped off, and they don't fall over dead all the time. So they clearly do have the capacity to recover. And this is where it brings us back around to our original comment that most of the time, collecting increment cores has, in follow-up studies where people have gone back to trees that were cored, sometimes cut the tree down and dissected it to see what happened around the core area, they have found no damage. And that is because trees have the ability to compartmentalize wounds. This is not true for animals like us. If somebody stuck one of these increment borers in us, it would perforate many organs, blood vessels, bad things would happen. But in the case of the tree, it's penetrating these wood cells, so they're like tubes, tracheids or vessels. They're these long vertical cells, and they seal off. They close. They stop conducting water, and they seal themselves against the entry of fungus into those cells. And that formation of a compartment that compartmentalization of the wound, is effective almost all the time. It's so effective in conifers that in the case of conifers, we really don't have concerns at all about taking increment cores. In the case of certain species of angiosperms, that's where one has to look more carefully and in certain instances consider doing some other procedures. The other procedures are either don't take increment cores from these trees. Another procedure that has been tried is to use a disinfectant, something that will kill fungi, and dip the increment borer in it between each time that it goes into a tree. So that's kind of a general overview of this issue of damage to trees.
Excuse me, sir.
Yeah.
There is some specific standard method for single space, like some kind of species. One species there is some standard size is there. Above the size we can take the sample through borer. Like per specific size there is some standard measurement.
For taking sizes
Yeah,
of trees?
yeah, size, yeah, per specific.
The only thing that's really relevant to the size is if the tree is very small, then even a small core can actually be pretty much damaged to the stem.
No, like for this particular species, there is some standard rule or something is there. From this size only you can take the sample, or below that size you can't take the sample.
Okay. He is saying that there is some kind of a protocol that this size is ideal for taking core, and this is not. This is vulnerable, or this is likely to be infected.
No, as long
that
as
kind
it's
of question.
bigger than maybe 7 or 8 centimeters, anything larger than that will be okay. Yeah.
So we know that conifers are very big. So what if the bifurcation occurs above the CBH? So being looking at their size, they both can behave as different trees. So will we take samples from both of them or from CBH only?
Well, it gets to, once you have bifurcations that are higher and higher in the stem, then really that's just the canopy of the tree. I mean, the tree itself is going to branch and spread in different directions. So most of the time in most applications of forestry and ecology, if there's branching above breast height, then it's still just considered one individual. The place where people have concerns and have to make specific protocols to help them decide is when the bifurcation is right around this breast height measurement or even lower, as we were talking about earlier. Okay? All right, so let's go. I think Satish said that we would have tea every day?
Yeah. 11, yeah.
Okay, yeah. So we'll go. All the interesting trees are in the garden though, so
Yeah.
I would like to core the gardens.
The man himself called.
Illustrations. So they call this the thorn forest for real, huh?
Yeah. It's like semi-arid.
Let's see. That's the other side. Well, maybe we can. You guys see. That's the other problem. The problem is everything's got thorns. So I can get it.
Yeah.
So we are going to try this tree. You want some help getting through? Looks like you're clear.
Yeah.
Okay. Okay.
पीछे आपको बैक पे गंदा है पीछे गंदा है देख लिया
We need some machetes. A better potential to form tree rings, so that's why we're going to try it. That's why we're making such an effort to get to this particular tree. Okay, so in preparation, I'm going to, yesterday I went out and cored a few trees with one of the increment borers that I have and ran into several problems. So I'm going to try the other increment borer now. This is the largest one.
Chances are there, you will find ring.
Feature that we did not talk about in the garden is what happens on a slope. So yesterday in class we mentioned one of the principles of dendrochronology is this idea of replication. That at a particular site, if we wanted to develop a chronology, we would collect numerous trees, numerous examples from trees, and we would collect more than one core per tree. So right now, I'm not going to try to do that, but I want to bring that up first of all. So let's say that if we were trying to develop a chronology, we would probably want to collect 2 cores. If we're going to collect 2, we'd probably try to collect them at right angles, 90 degrees apart. That allows you to capture probably as much variability as possible in the different ring widths around the tree. If the tree is on a slope, how does that affect the way that it grows? Does the tree still grow straight or does it grow crooked? It grows straight. Sometimes it starts out kind of crooked, but it tries to pull itself back up, right? And so that anatomy, the anatomy of the tree is actually different because of the fact that it has to work against the slope. So typically when there is a slope, we want to take a core on the side slope. That is not from uphill, not from downhill, but from the 2 sides of the slope.
So,
Even if it's a very severe, or even if the tree is actually crooked or whatever, like growing like this, you still would take it from the side rather than from above or below, because it's more average growth. So when you start to core, you need to be careful with the extractor. If you just set it on the ground, it's easy to step on it. This can bend pretty easily. It's strong steel, but it's not that strong because it's very thin. Okay? Nice job. Good work.
Yeah, clear.
Okay. So I come in. Here is breast height, 1.3 meters. So I set the borer against the tree, and I try to visualize my way to the center as best as possible. If we can see rings in this tree, then I'll show you, then we'll see whether or not we came close to the center, and I'll show you how to adjust in the subsequent core. Okay, so the next part is, if I just turn the increment borer, nothing happens. There.
Very hard.
Nothing happens. Because this would at the same time to get the increment borer to start. But now the teeth have gripped into the starting to move in. Sorry?
This is when they take it.
It's tilted downwards a little bit, yeah. Yeah, so it's tilted downwards a little bit. I can still sort of adjust it, but I can't adjust too much. I definitely don't want to pull on it very hard because I'm going to start breaking the core that's inside. What I would like it to be is going straight for the center of the tree, and I'd like it to be flat like this. But it's going downhill a little bit, so that was my mistake. But it's pretty good.
Pretty
now.
good, yeah.
Okay.
Not too hard.
So how can I tell how far into the tree I am?
What the sound is showing?
The sound does change, yeah. So especially in a very large tree, when you move from sapwood into heartwood, the sound starts to change.
Yeah.
But that's not a perfect way to tell. There is actually a perfect way to tell. Does anybody know? Exactly.
Yeah.
Remember, this is the same length as the extractor. So if I put this right here, that's how far into the tree I am.
Yeah.
Am I past the center? Oh yeah. right? Quite a ways past the center. You guys see it on that side? So this is, you have your own instrument to measure how far into the tree you are. So now there's, in the center of this shaft is this core. So I put the extractor in with the cupped side upwards. Okay, so I put it into the bottom of this hole, it goes in. Now it contacts the wood and it slides past the core, and I push it in hard and lock it. So now there's a core in there, but that core is still attached to the tree at the back end. So if I go back, that breaks it off. But now the extractor is upside down, so I'm going to go back a full turn, not a half turn. Now the extractor is right side up again, and the core is sitting, one hopes.
Yeah, it's sitting.
Oh man, it does have rings.
This has
Sure,
ring.
it has rings.
Yeah, that should have ring.
And you can see that we have come right next to the center. You see how it curves around? So we have come very close to the center. This is nice. I'm going to have to watch this movie when we finish it. Okay, can you guys see? All right. This end piece is loose.
Yeah.
So I'm going to give it, can I give it to you?
Yeah.
Hold, don't lose that.
Yeah.
Put your finger on top of that. Yeah, there you go. The increment borer has to come out of the tree pretty fast because the wood compresses back around the borer. It's possible to have the borer go in and not be able to come out. And we don't want that to happen. And there's the hole left behind by the increment borer. So you can see that's the extent of the sampling. Okay. Are there people in the class who've used a forestry diameter tape before? You have? So you know that this hook goes like this around the tree, and this one's rather worn, but the zero is right there. So right there, for instance, would be a 10 centimeter diameter tree. The tape is going around the girth, but the units are reading off in centimeters.
Okay.
Does that make sense?
Yeah.
Okay. And then you wind it back up like this. So would you please take the diameter of the tree? Going good with the GPS? Okay, I'll let you play with the menus on that and see if you can figure it out. It's got to turn on and it's got to find the satellites. Okay, compass. Do you want to do it? So, what we want to do with the compass, is detect the aspect, the direction of the slope. What is the direction of the slope here? It's confusing, but downhill is like that. So we want to know what the compass direction is going downhill.
Northeast? 17.8.
Okay. This is a clinometer.
What is it? Sorry, what is it?
Clinometer, like
is it?
incline, C-L-I-N, ometer. And it measures slope. It measures inclination, so hence clinometer. Where did the core end up? Who has the increment core?
Increment core.
Okay. Can we have the increment core back to the center? Be careful not to lose that little piece. 17.8. So we'll come back to these measurements, but typically every time we core a tree, we have information about the tree that we want to save. We want to know the species, the location in terms of the GPS coordinates. We want to know the slope of the hill. We want to know the aspect, which is the direction that the slope faces. And and then we need to guard the core itself. So as you can see, the core is very fragile. One piece already separated as we were extracting it. I think it's been dry here for some time, right? So when I was coring trees yesterday, the wood separated quite easily, and usually that happens when the wood is really dry, because the trees have been taking the water out of the soil and there's not much water left in the tree. Okay, may I ask you to hold this and put a finger specifically on top of that?
So I just have a
That little
question.
piece. There you go, excellent.
So do we have any preference for season as well?
To collect the increment cores?
Yeah. Like you just said, you know, dry soil and wet soil.
It's not really a problem. It just means that we have to be very careful if it fragments to make sure we don't lose anything. Another seasonal issue is that in temperate systems, when the rings are forming, then there's a growing season and a dormant season. So if you collect during the growing season, you're going to have an incomplete ring at the end. That's not necessarily a problem, but for instance, in a forestry application where you're concerned with growth of the tree, then you can't use that last year because it's partial. So maybe in a forestry case, you might want to come in after the growing season to take your samples. So we have some very high technology for guarding cores. Does anybody know what it is? Yeah, straw. We have plastic straws and we have my preference, which are paper straws. So I'm going to use the paper straw, but the plastic straw can be used too. In the case of the plastic straw, you have to bring tape to close the end of the straw, or else it'll just fall out. Okay. So the paper straws are very nice for several reasons. First, we can make it the length that we want by cutting it. We can also write information on the straw itself. So we're going to write down the information about this tree on the straw. We can pinch the end to seal it off like that. All right. Now, gently move your finger away. Let's see. It catches a little bit in the teeth here, so it takes a little effort to break that piece free. And I didn't want to lose this other piece. When we start collecting, we'll go back in FT, and then after that, when we start collecting, you will notice that you're going to have little pieces flying all over the place because it's just hard to keep track of them. So now I put them all in the exact order that they came out of the tree, and I close this off, and it is now secured. Now I need to record information. Were you able to get a GPS? Okay, so let's just take that back. Let's head back, and because I think it's time for tea, and then we'll record all this information, and then we'll come back out and do more. All right. So thank you. That was one tree core, and it had rings, so that is perfect for us. Okay, let's find our way back. MSc में भी डिजिटल वर्क किया है और ये भी काम हुआ है. So you're coming back to that idea of the aggregated factors. Arid region growth is an aggregation. Oh, okay. I see. So you cannot tell that just by looking at the tree rings?
You have to,
Another possibility sample in such a way as नहीं अच्छा लग रहा है सर YouTube पे डालेंगे ना try to compare growth in the plantation natural trees next to it, yeah, something like that.
there is no specific Is there any process, any device, something like that which
we were using to take information about the tree and the site while we were collecting the samples. And what we'd like to do for the rest of the morning, we have about another hour and a half. We have 3 increment borers, and we have some ideas about which species may form rings. So we're going to go out and try to collect a few more samples. It's not so much the number of samples, it's more that everybody should have a little bit of experience feeling the increment borer, trying to extract a sample, looking at the sample coming out of the tree, etc. Okay, so we're not in a hurry, but if each group collects maybe 2 samples, then we'll be good. Each of 3 groups. Okay, so this is a diameter tape. So it's a regular tape measure, and on the inside it has normal centimeters. This is just 10 centimeters from 80 to 90, 90 to 1 meter, etc. But the side that we use on the tree is the other side, and it has numbers that are spaced much farther apart. The reason is these are the centimeters of diameter of the tree. So when we wrap this around the tree, let's see if this is going to work out. If I'm a tree, we wrap it around the tree. See where it says 1, 2? There's the 0, which is this blue little pen mark. So we just line up. So my diameter is 26.5. Does everybody see that?
Yes.
So that's not the circumference, that's the cross-sectional diameter. And thus the reason that these units are so far apart is because they're centimeters multiplied by pi.
Yeah.
So that's the formula for converting from circumference to diameter. So it's a pretty simple tool, but pretty useful. And of course, one could measure the circumference or the girth instead of the diameter if that's the kind of tape you have. The GPS is, there's many different kinds of GPS, and a lot of people have GPS on their phone that they could use as well. But we simply took a waypoint at the site. So we have coordinates in UTM. I don't know if that's what people commonly would use here. It's most common for us.
Here, geographic lat long.
Lat long?
Yeah.
Okay. So we tend to use UTM. One nice thing about UTM is that these numbers are in meters. So if I go 100 meters away from this point, I'm going to get a number that's 100 meters different on the axes. And that's useful for helping you locate yourself because the lat long is a little hard to understand. And I'm going to write down that point and keep a little log book. So I called this tree number 1. This was Azadirachta indica. So I'll write down the UTM coordinates. The diameter was 17.8, right?
Yeah, correct.
Yeah.
Indica, as a written.
Diameter से बताइए species.
Okay, so the next tool is the compass. And the compass has a movable arrow with red and black, and then it has the background. On the background is also printed a red arrow. So if I line up the movable arrow and the printed arrow, the compass is now pointing north. So if I wish to know the direction that the slope faces, let's say this is flat, obviously, but let's say it's going downhill like this, I can line it up to point north, and I see that that downhill direction is about 85 degrees. It's between 80 and 90. So that's the aspect, the direction that the slope faces. It's also possible to point the compass in that direction and move the needle. Well, sometimes, and some people are very familiar with the compass, but others are not. And so when people are not that familiar, it's easier to just line up the compass and then just hold it lined up and look at what direction your slope is going and write down that number.
But it's always reference point is north.
The reference point is, I mean, the red needle is always pointing north.
North, okay, yeah.
Does anyone know what the declination is here? The compass declination? The difference between magnetic north and true north in New Delhi? Do you know what it is?
Magnetic.
East or west?
It is east.
No,
Okay. I don't know.
Yeah.
I'll look it up online.
Yeah.
Because you guys don't sound totally certain. But
east west, yeah.
okay, the reason is that there's a slight angle between true north and magnetic north.
Yeah.
The needle points to the magnetic north.
Yeah.
That's why the red needle painted on here is not right at north. It's offset a little bit.
West. Yeah.
But it's offset for where I live, not for New Delhi. So. However, for the purposes of what we're doing now, we're okay. But for a real field collection, you would want it to be right. And then the last one is the clinometer. And the clinometer measures inclination or slope. So what we can do is ground. So if I wanted to know the slope from here to the next level up of the building, I can look through this eyepiece and I can see numbers and I can see it move when I change the angle of the instrument. If I look up at that next floor, if I want the slope from this floor to that floor, then I have to look from my eye height to the eye height of somebody up there. So it's helpful, for instance, to have another person move away from you on the slope and then you look at their eye level or wherever your height difference is on that person. So I look up there and I have two different scales. There's a left hand and a right hand scale. One of them is percent and one is degrees. We usually use the percent. It doesn't matter, you can use either, but you have to be consistent because if you switch from one to the other, you get very different answers. So if you go to the end of the scale, we see the next floor is an angle of about 38%, something like that.
From the height of your eyes.
From the height of my eyes to the height of to the height of me standing on that next floor. Yeah. And so percent is just the percent from 0 is flat. This is 100% is 1 to 1, and then it becomes very, very high percentage as you get higher above that.
90 is 100%.
45 degrees is 100%.
45 degrees is 100%.
उसमें आपका base and perpendicular दोनों equal होगा.
So if you look through the hole, you see the two scales, and it's the one on the right.
Okay.
There's also an external scale on the side of it that you can also read off in degrees.
So just coming back to compass, what do you do with true north and magnetic north?
So what you do with it in the compass is you change the declination in the compass.
Okay.
So you see the red arrow is not pointing right at north. And if our declination here is possibly 11 degrees west, or 7?
7.5.
Okay, so then we want to move the red arrow so that it's pointing over there. And we can do that by turning the screw in the back. So we put that thing in there.
My question was basically, you are just correcting the orientation for the field data collection, or there is some other use for this?
Well, the purpose is that now, if we have it set correctly with the declination, now that's really north. Okay. Before it was off by about 15 degrees or so.
Oh, okay, you have to adjust from there.
Yeah, you can see it on the back. So that's 0, and then there's 10 is buried, so it's at about 7 now. So it's about 7 degrees west.
Okay,
so if this is our correct declination,
so but it changes over the time. So from where do you get that value?
The 7.5?
Yeah, or 11.
Usually
it's not constant.
No, it's not. Usually the geological survey of a country will maintain like a map or a website? with the
Okay,
values?
so what we do with this is, when we have a topographic sheet, so when it was prepared, what kind of, deviation was there, so we, while surveying, we try to correct ourselves using the magnetic north and the north which is mentioned on the topographic sheet. And then we actually get to know if we want to identify location for some sampling and all. So there, correction of the information which topographic sheet is giving. So we carry out that for surveillance.
Yeah, on our maps also is printed.
Yeah,
There's
at
a
the
little
top.
deviation,
Yeah.
little
Yes,
arrows.
yes, yes.
But it does change. So if the map is 20 years old, then it's already somewhat different.
Yeah.
But it doesn't change that much.
But
I mean, it's slow.
the way objects are shown on the map, so those corrections are done, and you actually get hillocks or a particular type of tree or any other kind of control point you can identify, and you can quickly reach to that. So I was just wondering, as a forester, irrespective of these topographic sheets and all, as a forester, how do you use this value? Just to correct your north. That is what I understood from you.
I might not be understanding your question, but the declination adjusts so that now the compass is pointing true north.
Okay.
That's the point.
And how this information is useful? Only a reference point, or somewhere used in interpreting the results?
So when we measure the aspect, the direction that the slope faces, that can be very useful because in the northern hemisphere, for instance, south-facing slopes are usually much drier than north-facing slopes.
Right.
So the characteristics of the site influence the tree growth.
Okay. Okay.
In terms of navigation, it can also be important because if your compass is not pointed correctly, then you could be off and wrong.
But it is not factored in the final calculations. For example, in dendroecology,
The declination doesn't have anything to do with
nothing
the tree
nothing
rings.
to do with the connection.
Correct.
Thank you.
So,
resource person. Important. That's our experience.
It can grow in very stressful. Yeah, we have Pinus roxburghi growing here. It is far. Yeah, it is in Basantpur.
Excuse me, Peter. Have you identified any?
ये तो ल्यूसिना है. ल्यूसिना लिकोसिफाला. सुबबूल. बंगाली बबूल.
see, do you have that
Yeah, that one.
chronometer?
Yeah.
Okay.
A lady is bringing that. Yeah.
All right. So let's make this be our central spot. Course. Okay. Would you want one of these? Okay. So, Satish, will you stay with us for a bit? Okay. Would you like to take a group with your borer? And then, is there someone else who had some experience? You have some experience?
Yeah.
Would you take this borer? So that borer is the one we just used, and it seems to be working pretty well. This borer I know has problems because it's got stuff on it. Oh, that's glue. The glue must have spilled in the bag. Shoot. I brought some glue to show how we mount the cores, but I might just be showing you how we get glue in the bag. but I'll work with this. So what I would propose is that we have, these are the Arazita, right? Yeah. So we have 2 of those trees here, and I think we can get those with rings. And then we can try some of the others.
This one is in your bag.
Lucina?
This Lucina is having softwood, so we can try
This one here?
Yeah.
Okay.
Yeah.
All right, so let's try that.
But
And let's try to get between 2 to 3 cores per group, but it's not a big rush. I have the notebook here, and we can record, so don't number your core until you come back here and see what the next number is. Okay? Because we have number 1, and let's say you get one, you come back and you see that number 3 is already down, so then yours is number 4, like that.
Yeah.
Okay? I don't think we really need to, the slope and aspect is very similar here in the location, so we don't need all that, but we do need the diameter of each tree. Let's take the diameter of each tree separately. Okay?
Yeah.
Yeah, thank you. Let's try to take more. Thank you very much. All right. So,
तुम क्या क्या सोच रहे थे ये बताओ
you do that one? Okay. And Santish, would you take about a third? And whichever tree you wish. I'll take the remainder. It's one
ल्यूसिना में जो है ना रिंग का मुश्किल होगा थोड़ा सा
easy है लेकिन
ना इजी होगा लेकिन फास्ट
नहीं उसमें रिंग नहीं बनेगा.
फास्ट ग्रोइंग है बहुत फास्ट ग्रोइंग है.
प्रोसोपिस ट्राई मत करना, वो जैम हो जाएगा.
यो करो वो करो अकेशिया ल्यूकोफोलिया
Folia?
ल्यूकोफोलिया.
That white part what?
This side the close one here or the farther back?
वो प्रोसोपिस की तरह होता है.
अरे वो उधर है सर वो साइड है
सफेद है सफेद इस टाइम.
So that has to
आप क्या
open
कौन से उसमें करती हो अनुराधा काम?
and then close.
जो
Put it about there. And then kind of aim to the center of the trees.
DHU.
दबाना जैसे.
DHU में जियोलॉजी का कौन है? रघुवंशी के साथ.
नहीं रघुवंशी सर ISD में थे. इन्वायरमेंटल सस्टेनेबल डेवलपमेंट
में कौन था वहाँ पे?
मधुलिका.
अच्छा मधुलिका अग्रवाल. हाँ उनका तो काफ़ी अच्छा काम है. आई हुई थी अभी तो कुछ दिन पहले.
शिक्षा सर के साथ कोई आपका बंदा के शिक्षा सर
How's it going?
Good.
Press it.
ग्रीन हाउस कैंपस में एक
वापस आ रहे हैं.
2012 फॉर दैट क्या है वो टीचर्स ओरिएंटेशन प्रोग्राम्स होते हैं. यार रघुवंशी ने बुलाया.
मैं ट्राई करूँ.
नहीं जा रहा.
थोड़ा सा पुश करो हरप्रीत.
That was looking good.
नहीं
there
दोनों
at the
हाथों
end,
से
yeah.
दोनों हाँ या थोड़ा ये नहीं हिलाना नहीं है स्ट्रेट.
ये फ्रेश करना है राइट हैंड. हाँ ऐसे. नहीं जा रहा.
तो आप लोग भी करो. आप लोग भी करो. Have a feel.
Your weight into it
Yeah.
and try to have it move forward as you're pushing in.
एक मिनट. Just. I thought it is very easy to
Huh.
pierce birches.
Yeah.
But birch
Huh.
is very hard.
Yeah, that's curious. I don't know why.
Yeah. Because of that cold climate, maybe.
We work a lot with populus, which is similar.
Yeah, yeah.
And it's pretty soft.
एक मिनट दिखाइए ऐसा ऐसे 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 ना मैं आप ही को दे रहा हूँ
हाँ हाँ नहीं अब हैंडल घूमने लगेगा शायद
एक मिनट
Starting to go for you? Looks like it. It's nice and straight too. Is it good right to left? Going towards the center?
हल्का पुश बॉडी का भी देना है ना
नहीं अब शायद
सब करो आप लोग आप सबको दे दो थोड़ा थोड़ा आप भी करो आप क्यों दूर खड़े हो
If it gets very hard to push and you get concerned, then let me know and I'll test it.
हाँ आपका हिल रहा है हिलाओ मत उसको
It is
बॉडी का
possible.
कांस्टेंट प्रेशर के साथ कांस्टेंट प्रेशर विद बॉडी एंड स्ट्रेट हैंड्स जोर नहीं लगाना उसमें सीधा जोर नहीं लगाना कि वो टूट जाए हाँ इनका भी हाइट का वेरी नाइस वेरी नाइस वेरी नाइस वेरी नाइस वेरी नाइस या या
She was the secret strong one.
she is good she is good वेरी नाइस अब देख लो एक बार अब हो गया होगा शायद लगता है
देख लीजिए
और घुमा दो
learning new thing is always yeah very elevating yeah
True.
ecology
नहीं आप पर तो नहीं हाँ हो गया बताएंगे आपसे थोड़ा ज़्यादा ही हो गया
physically
आपसे हो गया
robust mentally very strong but then they are using those age old methods
बिल्कुल बिल्कुल अब आसान हो गया
difficult to draw young people talented people in the field of ecology they abhor that kind of work where you have to compromise with the rigor of science they think
इसको
like
करना कैसे इसको मुझे
So it
लॉक
is
करके
more
देना
rigorous, more challenging. Yeah, but at the same time, dispel the youngsters.
It will be like this
Okay.
direction.
So, all right,
रुको
so
रुको
let's,
रुको रुक जाओ जरा थोड़ा वो ले लो
so
गाइड ले लो
that's right. Go
Yeah.
ahead. Right side up. So we have the handle level. That way we
Yeah.
can tell when we make a turn back.
yeah now push gradually
Now here you have to, at this part you have to be careful not
Yeah.
to push too hard because
Yeah.
you can bend it.
yeah
Slowly. Yeah, it's gradual. So see if I do like this, it helps me not bend it so much.
yeah
Because it's very dangerous at the end. You can bend the extractor and then, yeah, don't do it that way. I have bent and broken everything that can be bent and broken. That's as far as it's going to go for now. That's
Yeah.
why this increment borer has a problem. So now go one whole turn back.
Like this.
Back.
पूरा 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 बस 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 अब यहीं पे रुक जाओ
Another half.
another okay दम ये टर्न हो जाएगा पूरा yeah
Okay.
yeah
And stop. Now it's right side up again. Now you try to pull it out. See if you can get it to come.
आराम से
And then just come
very
gently.
gradually very gradually
Coming, okay. So there are some broken pieces up here. So this is very fragile. Why don't we, but it does look really good. You can definitely see rings. You see that you guys see the lines, the striations, the rings? If these are all annual rings, this is a pretty old tree. This right here.
yeah
That's going to be very interesting to find out. So
it should be more than 30 years 25-30 years
So what I would suggest is, let's take this very carefully. It's good to put your hand over top of it like this and hold those pieces down. And not let them do what they were just trying to do for me. Or hold it like this. And then take it over there by the straws and let's do it on that little table. I'm going to back this out. Let's take it over there and do it over there.
very good very good
Yeah. So just take it all the way out and then join us over here, okay?
Okay.
Is it now? We don't know for sure which section is which. So we really want to try to avoid that. We don't need that piece anymore. So we can cut it like that. We can take. Oh, they have it. It's okay. It's fine. And then we can slide it in from either direction. I'm going to go from this direction. From either direction we can use. Yeah. And those were all the dangerous little pieces, and now the rest of it is pretty easy. Okay. So you guys have number 2, right? So did you call it 2A or 2B? Or can you call them 2A and 2B?
2A and 2B.
Instead of 2 and 3, okay? So then ours will be number 3. Yeah. So can you add us as number 3 on there and put the species, and then we have to get the DBH. So we need the DBH take back from now. Same species, except I scrubbed that one. Alright. So where did our increment borer end up? You had it? Okay. Actually, may I have more?
DBH किसी ने मेजर किया
We have to measure it.
TBH होगा TBH होगा
एक साइड तो डायमीटर डायरेक्ट इंच में
नहीं 31
ये ब्लू लाइन
आपने वो मेजर जो गर्थ है
नहीं सर उसमें डायमीटर का वेट
आपने
इनसाइड दिस डायमीटर
इसकी यही अच्छाई है एफपी की दूसरे साइड वो डायमीटर कम है कन्वर्ट नहीं करना ओके सो 31
सरकमफरेंस
No. Actually, this is the tree.
it has
Group, let's go back to that big tree back there.
Ficus. Yeah. Morus.
Well, what's this very large one over here?
This is ficus, and it will give you rings. Probably. Yeah.
डाल दिया
नहीं कोई और एक और ट्री ट्राई करते हैं
ये इस तरह पोस्ट ऑफिस है क्या?
So are they edible? Like the fig?
Yeah.
not right now I guess
But not right now.
not right now yeah.
They are edible.
They're beautiful.
Yeah. Figs.
Okay, why don't we do this one? It's easier to see the whole stem, you know?
Yeah.
Makes sense. Be more easy to see the rings. And depending how it looks, maybe we'll take 2 from this tree.
Not body, but wrist. Wrist और दूर से पकड़ो.
नहीं अभी तो यहाँ
अभी तो
पकड़ो
यहीं से होगी स्टेबल करना
अभी वो हिलेगा ना
इसमें आसान
तो इजीली हो रहा है दिख रहा है ये पता नहीं
Ficus
सर में दम ज्यादा है
आसान तो होगा ही. पर जैसे अंदर जाएगा ना, उसमें सैप
बाहुबली हो गया आपको
और सैप जो है उसको थोड़ा सा दिक्कत है.
I'm gonna leave this with you for a minute.
अब आप घुमा सकते हो
अब थोड़ा सा प्रेशर देते
ये
हैं.
तो बहुत
प्रेशर नहीं चाहिए
आराम से हो रहा है
आराम से हो रहा है
चौधरी जी को भी दे दीजिए
ये मैं भी ट्राई करता हूँ
वो धीरे धीरे हटाते रहते हैं ना बाद में, वो धीरे धीरे हटाते रहते हैं।
CBH, not the CBH.
ये CBH है।
अब जरूरत नहीं ताकत लगेगा रुको
एक बार देखते हैं आर पार होगा
मिडिल तक बस
आर पार में फिर आप एज नहीं निकालते,
जरूरत
पिच तक ही
डबल हो जाएगा फिर।
नहीं
पिच
क्या होता है
नहीं पिच तक हो जाएगा।
वो कहाँ है
हो गया।
रुक जा भाई, ये आप दे दो इसको भी।
करिए करिए।
इजी है सर।
नहीं अब
सर थोड़ा ऐसे खड़े हो गए ना, इसके
एक बार ही करना।
फेस करके ऐसे
अब पहले हाँ ऐसे ही करना।
हाँ पहले सीधा खड़े होना है,
खड़े होना है सीधे यार।
बस 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 बस
हो गया बस।
देख लो।
Yeah, that's probably good enough. Okay.
enough, sir.
Yeah.
ट्राई।
इसको सीधा कर दो, इसको स्ट्रेट कर
हाँ
दो, बस थोड़ा सा, बस बस बस। पीछे ये आराम से।
नहीं नहीं नीचे से जाना।
They're on the.
आराम से अब धीरे से बस।
There's a whole.
अब आगे पकड़ के यूं
There's a big
आगे पकड़ के पीछे
पूरा पूरा पुश करना।
अंगूठे से या
अभी थोड़ा
ऐसे नहीं ऐसे नहीं। हाँ
वैसे पकड़
टेढ़ा हो जाएगा सर।
दबाइए। नहीं ये अपने दोनों हाथ को उंगली पे हाँ ऐसे रखिए। चलिए। गुड 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 बस। हो गया हो गया हो गया हो गया।
ये बाहर रहा है।
एक सेकंड।
बाहर पिछली बार था बाहर था।
That's good enough. That's good enough.
That's
Don't push
enough.
any harder. Okay, come back. One whole turn.
one whole turn.
This increment bore and the extractor are from two different places, and so they don't match well. So that's why you can't push it all the way in. Okay?
निकालिए धीरे।
Slowly slowly slowly।
Slowly slowly slowly।
Nice.
Very nice।
Beautiful.
ये तो पूरा है।
कट नहीं हुआ।
नहीं एक जगह ब्रेक है थोड़ा सा।
Would be
ये
maybe
लेके
indistinguishable, or you find that
I mean, it looks like rings.
Yeah.
It looks like lots of rings.
Yeah.
It looks quite old. This is a little bit of a scar in here.
Yeah.
This is some kind of an injury that it had. I think it's pretty old, and even though we were quite far in, the rings turn because the center was over here.
Yeah.
So when you
we went beyond the circle, central point.
We haven't reached the center, I think.
we're parallel to the center, but we're offset. So remember, we put it in right side up like this. We came back one whole turn. So this is the original orientation in the tree is like this. So now we know that the center is this direction.
Yeah.
So if we wanted to try again to reach the center, we could take this core, put it back in the hole to guide us, and move over and go parallel to it about 2 centimeters over, and maybe we would hit the center then. So you can use that information as a clue to adjust. All right. It looks great. That's a very nice. So should we take 2 from this tree?
Yes, 90 degrees.
Yeah, let's try.
From here?
Parallel
Yeah.
or on perpendicular.
Perpendicular. Yeah.
उधर से।
So where did the straw go? Okay.
इसका सब diameter ले लो।
And you can either use a drill like a construction drill, or you can use the motor from the chainsaw. And the chainsaw can have sort of gasoline power, and it can have a drill attachment that attaches to the engine.
So is that used?
It is used, but it's not as helpful as it might seem. So once you are able to do this, once you get used to it, you can core many trees of this size.
Anyone
quite
else
quickly.
want to try?
The only time that motorized equipment is helpful is if you have many very big trees to core. and in that case, it ends up being faster. But for trees of this size, because you have to attach the drill, then you drill it in, you have to detach it in order to pull it back out. So it ends up not saving too much time. The other thing is, unfortunately, it can hurt you because the machine can make so much force that if the borer stops, then you keep going. And it jerks your arm and your wrist.
ये सेंटर की तरफ जा रहा है ना?
It can be used. Yeah. It can be used.
Have you seen people using it?
Yeah, I've used the chainsaws. And we had a situation of a forest with many old trees, so there were hundreds of very big trees to core, and it was helpful for us. Were you guys, did it work? Hello.
I don't think it's.
Sir. Were you able to skip the?
ये थोड़ा ऐसे नहीं जा रहा है?
Okay, so
आप लीजिए ना।
ये थोड़ा ऐसे जाना चाहिए। हाँ।
मेरे में लीजिए।
वो तो दे दूँगा ना।
Try करने की
देखिए ऊपर वहाँ से आता है।
Try करने की I think it's not going to.
Anti-ecological study. You think it's not?
No,
it's not far enough? Or I don't understand what you.
No, I thought I'm thinking it's not in the. It's not going in the center. It's going. It's tilted. Probably.
95 cm, I think this is.
ठीक है.
CBH.
Okay.
कितना है?
95 cm.
अंदर नीचे वाला रीडिंग ले लीजिए.
क्या हुआ? काटा.
All right.
हो गया सर, हो गया.
हो गया.
हो गया.
We can make this be our last tree. And
30,
then,
30 I think diameter ना. 30 centimeter. ये यहाँ 30 है ना.
Okay.
Yeah.
That's probably about right.
ये यहाँ सर 95 आया ना.
It's hollow.
नहीं
It has no
इसके
wood in it.
एज पे मिला है ना ये जीरो पे. ये जीरो से स्टार्ट नहीं है. दिस इज द जीरो.
हाँ तो ये
जितना एक्स्ट्रा है. Don't be used.
Try not to push that way because if you push from back here, it can bend. So if you hold it so that, you know, with two hands, don't let it get so much force on it.
हाँ वो तो साइड इसका. I don't think it was out जाएगा.
ऐसे होल्ड करना.
और जगह नहीं बोला
क्या
हो गया उन्होंने बोला था कि वो बहुत जोर नहीं लगाना.
इस साइड से लीजिए. इस साइड से.
Weather is very perfect to do field work.
It is. It's nice.
That's
Cool.
29.6.
Californian forests are engulfed by forest fires.
Yeah.
Blazing these days. This is dry season for California?
Oh, it's not him.
So, what's happening is that this, so let's try just stick it back in and trying again. That just got it. So it just wasn't catching as well as it could. Okay. Nice. Very close to the center, right about there. You see the curvature? Okay. This ficus has nice rings.
Yeah. This one.
And if these are all annual rings, this tree is
But
old.
how curvature and then you are inferring it with the center?
Right there.
Yes.
Because you see how it turns?
Yeah. Okay.
You know?
Yeah.
So we just missed the center. The center is very close here. We were much farther away on the first chord. So this is good. Yeah, this will be an example too. We can see the difference in the age estimate that we get when we're closer far from the center. Very nice. So now with this one, so there's the center. We don't necessarily need everything that's past it. How much straw do we, what's the straw that we have left in? Well, let's take it back. Let's save the whole thing. But in a real project, sometimes you may break it off after the center if you don't need it. Will you take it out? Okay, let's go back to the clear ring.
Very nice, yeah.
Very nice. Yeah. And can you guys see that we're close to the center?
Yeah, this is pit.
This is the pit.
It's very close to the pit. It's not quite at, it's right to the side of it. But you see how they curve around. Yeah, so that means we're very close. All right.
Or A or B?
You guys want to start it? Yes, I don't know where the rest of the boar is. It's coming. Is that the other cord? No. This is just one. Oh, so use a...
कुछ इंस्ट्रूमेंट दिखा तो बच्चों को लगे दिखा रहे हैं कुछ अलग तरह का देख रहे हैं तो सिंपल टेस्ट
हमेशा टाइम के साथ इवॉल्व होना पड़ेगा
वही मैं
आप जो है वैसे ही छूट जाएंगे
हाँ उनको लगे कि हाँ ये भी कुछ आता है
Okay, so we have number 1, 2A, 2B, number 3. Where's number 4? Is that it? It's just one sample? 4A, 4B? Okay.
कोरा भी जो लिया हर प्लेट है आपने रख दिया
Where's your group samples?
With them, so they will be getting one more tree there.
Okay, so let's call this one number 5.
हमारा कौन सा था हर प्लेट अभी हमने जो लिया नंबर
5.
थर्ड और 5 हमने किया है
That's a sample. What is that? That's nothing? Okay, all right, so I'm going to call this 5A. And this was Ficus glomerata. Is that right? And the diameter we said was about 30? Okay.
सेंटर के पास
हाँ सेंटर के पास
Thank you.
अगर हम सर इसके आर पार करना है तो जो सेंटर के इधर दिखेगा जिसमें वैसी उधर दिखेगी
उन्हें चाहिए यूजुअली क्या करते हैं परपेंडिकुलर तो इसलिए किसके पास छोड़ करके एक ही उसमें बनी है ना पूरी तो अगर परपेंडिकुलर हो तो उसमें वो लेने
मतलब फिर पैटर्न वही रहेगा फिफ्थ के बाद पैटर्न वही रहेगा
नहीं हो जाएगा इससे बड़ा
उतना बड़ा का उतना बड़ा किस ट्री का है
It can only be as big as the increment.
It's like I'm telling about the girth. So we are going up to center.
This will be enough. We thought you'll need another one.
ये तो सर
एक संपर्क खराब हो तो बाकी
एक लाइट रिंग
यहाँ तक पर वो बहुत टफ ट्री है वो बेटुले
इतना
बहुत टफ
अटक जाता है
वेरी टफ
एंजियोस्पर्म में ये फंस जाते हैं
नहीं यहाँ नहीं फंस रहे लेकिन फिर भी आ गया
फाइकस का तो सर बहुत आसान है
Okay. Let's see.
उनको बुलाना पड़ेगा
शिमला तो रोजमर्गी होता है कूलर है
आपके सारे साथ
उन्हीं के पास somebody call them
We're still okay on time. We're still okay.
वो पेड़ को कहते हैं उसके बाद आएंगे
Well, they're getting the huge tree, but they must have the smallest increment board. Okay. Whatever.
Good.
So on probably on Thursday, we'll take these samples back and let them dry. And they can just dry right in the paper straws. If you use the plastic straws, you either have to take them out or take the tape off the end of the straw or something. But with these, it's okay, they'll just dry. And then on Thursday, we'll mount them. And this is one that I collected yesterday and mounted. This was from the legume like that in the back, which I think is acacia. So I really didn't see rings on it. But it's glued down with this is just a regular wood glue like you can get for carpentry. And then we use the rubber bands to hold it tightly and to hold all the pieces until it dries. And then on Thursday also we'll bring out the sanders. Well, we can't do that, we have to let it dry. So on Friday we'll bring out the sanders and we'll sand these down. And then we'll get a look at them in the microscope also. These are, I bought them, but I bought them in the US. They're sold in the US for art projects. People use them to make some kind of straw sculpture. They're not for drinking. So I don't know how available they are. But they're not very expensive, so you can buy a big box.
One, only one.
वो जिनको पेज के लिए चाहिए था मुझे पता ही नहीं किसके पास वो मुझे दे देना मुझे पेज ले देना मुझे याद नहीं है किसके पास है वो किसके पास है तो मुझे दे देना मेरे भाई वो तो एक थे मेरे पास जब मैं था हमारे पास 15,000 का
कितने हुए सैंपल्स टोटल?
नहीं दो और किए हमने
नहीं ऐसे नहीं ऐसे उल्टा उल्टा डाल दिया
नहीं ऐसे ही नहीं डालना है ये वाला साइड अंदर है
उल्टा डाल दिया
उसके अंदर जाए
Do you guys have other straws? Other cores?
कहाँ वो कहाँ है हाँ that's coming
Okay. Do you need the tape to measure the tree?
we had already done
Okay.
We haven't taken the measurement there.
We took the
Taken.
Ficus, yeah.
taken sir
We have everything
कल थोड़ी
for
करना है अब तो lab
these two groups, but we don't have any data for your group yet. So we need to write that down. So this one's yours, right?
Yes, it's mine.
Why don't you, let's just,
It's over now.
yeah.
जल्दी पद्मा
So oftentimes when you collect in the field, you have mini straws like this.
Yep.
You might want to make something like this to carry them in. Okay.
We have taken at different heights for two of the individuals.
Okay, so this is
Just
the
stem height and
Several species. Azadirachta, recta,
Ficus,
Morus alba,
Acacia,
Ficus,
Catechu.
Acacia.
This is Katachu?
नहीं,
Leucopholia.
Okay.
कोई शुरू में कटेचू बोला था
कटेचू है नहीं
White. PHLOE. P है ना?
PHLOE.
हाँ.
LOE.
Leuco white.
So, for right now, I'm going to keep your group separate because the numbers duplicate, so I'm going to put new numbers and we'll have a continuous, so it looks like we have about 12 or so trees, which is good. This would be a nice data set for us to look at.
Yeah.
When you do this for real in the field, you want to protect these straws. So what we usually do, we often are working in forest plots. So on one plot we may have 20 cores. We may tape those together in a bundle so that way there's less chance of something breaking or getting caught somewhere. And then we put it in a container like this. This is just a plastic plumbing pipe. So usually you can, I mean, I don't know how it is in India, but there's probably similar kind of pipe that you can buy.
Easily available.
And it's very strong, so it's very helpful for that. Okay, so let's go back. We have everything else, right? We're not leaving anything? No. All right, let's start going back. We'll let them dry, and then on Thursday we'll mount them, on Friday we'll sand them. So on Friday or Monday will be a good time for that to work the scopes. Paragraph about the work.
Yes. And also we talk about when we go there.
Okay, you should talk about
Leisure time, from scoring, everything.
Yeah. The other thing, I'll make a more complete list of what I think we need for the chainsaw.